Hello everyone, welcome to mindbraintalks, the place where you find diverse and scientifically accurate information regarding psychology, neuropsychology, neurosciences and research methods every single week. My name is Bruno Faustino. I am a licensed clinical psychologist and neuropsychologist who's been working as a therapist, researcher and educator for the past few years. Here, I discuss and describe lots of topics, themes and concepts from psychology and neurosciences for you to understand it and for you to learn something about it. All contents here are just for educational purposes and it's not intended to diagnose any psychiatric condition or neurological disorder. So, without further delay, let's jump for today's content. So, today I will show to you how to perform Pearson correlation in SPSS. As you know, Pearson correlations are a very used statistical analysis, statistical method or statistical test to explore associations between variables in psychology. Therefore, I think that will be very useful to you to see how you can do it in a simpler way in SPSS. I've used these 4 manuals to prepare myself to do this video, and I think that these manuals are very useful to study statistics, applied statistics to psychology, biostatistics, and to understand how to perform statistical tests in SPSS. So, if you want to check these books, please see the video description below. Before we jump to SPSS environment, I will give you some general notions about correlations to help you build meaning about what is a correlation. So, a correlation is a statistical test that measures the degree of a linear association between two variables. Typically, a correlation coefficient is expressed in R when we talk about Pearson correlations, or S when we talk about Spearman correlations. Typically, it lies between less 1 and plus 1. Okay? Forward, we will see how this can help us to understand the degree of association of two variables. And typically, when we talk about a correlation, we talk about a Pearson, a Spearman, Kendall or biserial correlation. One thing that is very important is that correlation do not imply causation, because if two variables are associated, does not mean that one variable is the cause of the other. So it's very important that you keep this notion in mind when you perform statistical tests, when you perform correlational analysis in your data and in your study. So, correlations typically fall between less 1 and plus 1, and correlations that are between 0.1 and 0.3 are described as small correlations or weak correlations. When correlations fall between 0.3 and 0.5, typically they are described as medium or moderate correlation. And finally, when correlations are higher than 0.5, typically we call this a large or strong correlation. Correlations are based on the parametric assumptions, which are very important to establish which kind of statistical tests that we must perform. However, I will talk about this in the future. Here I will talk about just some assumptions that we need to have in mind to perform a statistical analysis, or to perform, in this case, a correlational analysis. So, the two variables must be continuous. All variables must have cases and values in both variables. Okay, so it is assumption there must be a linear correlation between variables. We expect that these cases must be independent. Okay, we hope that the variables are not associated by any other means. Both variables must have a normal distribution. and the variables must be collected from a random sample from population, and we expect that are not any outliers in both variables. So now I'll show to you how to apply this knowledge to an hypothetical research problem or research paradigm. Please look to this problem as an hypothetical one, okay? This is not a true problem, this is not true data. I've made this up just to give you some illustration about how to apply, how to perform correlational analysis in some random data, okay? Please, this is not real data, this is not real persons, okay? So, let's go. Emotion regulation, it's a mental ability that allows humans to regulate and modulate emotions. Difficulties in emotion regulation may have some impacts on mental health and symptomatology. Emotion difficulties are positively correlated with symptomatology. Okay? I think it's fair to infer this operant condition to be tested as an hypothesis. Okay? So our null hypothesis, it's when we have no association between emotional difficulties and symptomatology, and our age 1, it's when we find some association between these variables. As I said, as we find association between emotional difficulties and symptomatology. Of course, what we are expecting here is to reject the null hypothesis, which is the rejection of an absence of an effect. So now let's jump to SPSS. So here we are in the SPSS environment, and I want you to look to this column here, emotion difficulties, and symptomatology, okay? Just these two columns here. So, how can we perform a correlational analysis here in this problem? We go right here to analyze, then we look to this word here, correlate, and then we select bivariate. Okay, I've selected already the two variables, but I will show you how you can perform this. You just click in this button here, and this arrow points to the right, and you just select emotional difficulties and symptomatology. Then we have here select the Pearson, because we are performing the Pearson correlation. Okay, and we go here to options. We just want the correlation coefficients, so we will not click here in means and standard deviations, neither in cross product deviations. Okay, so we can press continue. Okay, we can also standardize and customize some things right here, but also we will not perform this today. So it's very simple. I think we can move forward. Have our selected options, and now let's go. Okay. So, and you will have here this table here, and what you can see is that emotion difficulties are strongly correlated with symptomatology. Okay, you can see correlation is significant to 0.01 level, two-tailed. Okay, as you can see here, this value shows our p-value, which means this p-value is below 0.01, which means that our correlation is statistically significant. Therefore, we can imply that emotion difficulties are correlated with symptomatology. Okay, and that's just it. It's all for today. Don't forget to see the video's description regarding today's theme to see the manuals that I spoke to you in the beginning of this video. And also, if you like to leave a comment or a suggestion, please say something in the comment sections below. And also, if you find useful what you saw here, please consider to subscribe and hit the bell for notifications. Welcome to Mind Brain Talks, and I hope to see you in the next video. Bye! Hello everyone, welcome to Mind Brain Talks, a place where you'll find diverse and scientifically accurate information regarding psychology, neuropsychology, neurosciences and research methods every single week. My name is Bruno Faustino. I am a licensed clinical psychologist and neuropsychologist who's been working as a therapist, researcher and educator for the past few years. Here, I discuss and describe diverse topics, research findings and data regarding psychology and neurosciences, the best as I can for you to understand and for you to learn something about it. All videos here are just for educational purposes and it's not intended for any consideration about a diagnostic criteria or neurological disorder. Without further delay, let's jump for today's content. So today I will show to you how to do the chi-square test in SPSS. This video it will be framed on the tutorial section of the channel. I've used these 4 manuals to prepare myself to develop this video, and I think these 4 manuals are very good in explaining how we can use statistics and how we can apply statistics to every kind of psychological problem and how we can perform these tests in SPSS. So if you like what you're seeing here, please check the video description and you will find there these 4 manuals. So now let's look to the chi-square test. The chi-square test is a statistical test to measure whether there is an association between variables, but these variables must be related or independent. So another issue with this test is that the variables must be categorical. So they can't be nominal, they can't be continuous, they must be categorical, okay? And of course, this is a non-parametric test. We do not need normal distribution as an assumption to perform a chi-square test. So, similar to correlations, we do not provide, this test do not provide any inferences about causation. However, there are some assumptions regarding chi-square test. The variables must be categorical. It will be needed 2 or more levels for each variable. For instance, if we have a sex variable or a gender variable, we may have two levels, such as male or female. And we expect that variables must be independent observations. We expect that there aren't any relationship between the subjects and the variables are not paired. Also, we expect a large sample size, at least 1 frequency for each cell, and at least 5 for the majority, 80% of the cells. So now let's go to another hypothetical problem, a hypothetical research problem, and this problem is a made-up problem, made for me, just for educational purposes, and this problem is just to illustrate how we can apply the chi-square in SPSS. So, women tend to report higher levels of symptomatology than men. However, this association needs to be explored. It's just a made-up problem. So, gender is associated differentially with symptomatology. So, we have two levels from each variable: gender, male, female, and symptomatology, strong, weak. Okay? Our null hypothesis is just that we don't have any association, and our H1 hypothesis is that we find some association between variables. Let's go to the SPSS to see how to perform this analysis. So, we are here in our SPSS environment, and now we will look to our variables. Let's perform now the chi-square test. So, we go to Analyze, Descriptive Statistics, Cross Tabs, then we click here, then we have our variable, which is gender, and the other variable, which is symptoms. Okay. Now let's look to our menus here. Okay, we leave this right there. Okay, we will select chi-square. Okay, this is very important. It's here. We select the statistical test. Cells, we go here. We also have a standard option which is observed, but we will select also expected. Okay. Ascending, it's standardized. Okay. So let's go. What we have here. So here we will see our p-value, which is below 0.01 or 0.05, okay, which means that our chi-square is statistical significant. Okay, here we have the values, okay, but here we have our statistical significance. Therefore, we may think that there is an association between the gender, male and female, with symptomatology. Right there. Right there. Okay? And that's it. Okay, it's all for today. Don't forget to see the video's description regarding today's theme to see the manuals that I spoke to you in the beginning of this video. And also, if you like to leave a comment or a suggestion, please say something in the comment sections below. And also, if you find useful what you saw here, please consider to subscribe and hit the bell for notifications. Welcome to Mind Brain Talks, and I hope to see you in the next video. Bye! Hello everyone, welcome to Mind Brain Talks, the place where you find diverse and scientifically accurate information regarding psychology, psychotherapy, neuropsychology, neurosciences and research methods every single week. My name is Bruno Faustino. I am a licensed clinical psychologist and neuropsychologist who's been working as a therapist, researcher and educator for the past few years. Here, I discuss and describe lots of topics, concepts and theories from psychology to neurosciences, the best as I can for you to understand and for you to learn something about it. So, in this video, I will start to show you how to perform an one sample t-test. So, without further delay, let's jump for today's content. I used these 4 manuals to develop today's video, and if you want to check them, please see the video's description below, where you can find the link to each specific domain, okay? So, let's go. So, one sample t-test, it's a statistical test that is used to explore if a sample mean is statistically different from a known or an hypothesized population mean. Typically, it's a sample mean that it's used, that it's tested against a test value, and this test value is an hypothesized value of a mean in the population. This test is considered a parametric test because it has lots of assumptions. And also, one specific thing about this test is that it's not indicated for more than one group, okay? If you want to perform a comparison of a mean value to an hypothesized value, you use a t-sample test, but to utilize this, you must use only one group, okay? So let's see the assumptions. The test variable must be continuous. It must be an independence of observations. The sample must be collected from random parodying. It is assumed a normal distribution. Also, the homogeneity of the variances is always necessary, and we also have the assumption that can't be outliers in the distribution. So let's go to our hypothetical research problem. Symptomatology tend to be higher in clinical samples than in non-clinical samples. However, this assumption must be explored. Symptomatology, when we talk about symptomatology, we talk about the mean response in a given questionnaire. So we are talking here is that symptomatology is higher in clinical sample than in normal population. Our null hypothesis is the absence of effect, so no difference, and the age one is difference between means. Okay. So now let's jump to the SPSS environment. So now we are here in the SPSS, and we have here our variable symptomatology, and we will test if symptomatology is different from normal population, an hypothesized value of normal population, or not. Okay? So how can we perform this test? We go to here to analyze, compare means, and and is here one sample t-test. We click on them. Oh, I've already had selected symptomatology here, okay, but you can just drag it along right here. Okay, so I am using this value. This is an arbitrary value, okay, just to test, and we go to options. We have our confidence interval, 95%. Exclude cases analysis by analysis. We can continue. Okay, let's do it. So our output shows that, oh, okay, we look here, okay, this significance level gives us 0.000, which means that we must reject our null hypothesis. So I think that we have a statistical effect when we compare the means of our sample to the hypothesized value of 1.7, that it's a statistical inferences for population. So here we have the t-test, which is less than 17, okay? But here, this is the F, it's the degrees of freedom of our statistical test, but here is the significance of the test. So here we have a significant result, which means that we can now look, first we can look here to our hypothesis. So we can look that symptomatology is higher in clinical sample than in normal population. So there is a significant difference between the means in our sample and that hypothesized value of 1.7, that it's an hypothetical value for a normal population. So we reject the null hypothesis and we accept the age 1 hypothesis. Okay? So I hope that you enjoyed the contents of today, and don't forget to see the video description regarding today's theme to look to the references that I think that are very useful to understand these concepts. Also, if you like what I'm doing here, please consider to subscribe and hit the bell button for notifications. If you want to say something about these topics, please use the comment section below to express your mind. Welcome to the Mind Brain Talks, and I hope to see you in the next video. Bye! Hello everyone! Welcome to Mind Brain Talks, the place where you find diverse and scientifically accurate information regarding psychology, neuropsychology, psychotherapy, neurosciences and research methods every single week. My name is Bruno Faustino. I am a licensed clinical psychologist and neuropsychologist who's been working as a therapist, researcher and educator for the past few years. In Mind Brain Talks, I discuss and describe a lot of topics, research findings and research methods, and I try to explain to you the best as I can for you to understand and for you to learn something about it. All videos here are not intended to diagnose any psychiatric condition or neurological disorder. So, without further delay, let's jump for today's content. I used these 4 manuals to develop today's video, and if you want to check them, please see the video description below where you can find the link to each specific domain, okay? So, let's go! Today's content, it will be related to a tutorial section, because today I will talk about how to perform paired samples t-test. So stay tuned. So let's see what is a paired sample t-test. A paired sample t-test is a statistical test that is used to explore if means of two conditions from the same object or subject, such as pre-test or post-test scores, are statistically different. It's a measurement of the same observations over different periods of time, such as paired observations. Do you know, a paired sample t-test, it's a parametric test and explores the statistical difference between two time points, two conditions, two measurements or a matched pair. Now let's look to the parametric assumptions that we must have in mind when we want to perform paired sample t-test. So, the dependent variable must be continuous. There must be dependence of observations, the same group, same subject, same individual, okay? We must have a random sample of data from population. We expect that our data has normal distribution. We expect also homogeneity of variances, and we expect to have no outliers. So now I'll show to you how to apply this knowledge to an hypothetical research problem or research paradigm. Please look to this problem as an hypothetical one, okay? This is not a true problem, this is not true data. I've made this up just to give you some illustration, and I'll show to you how to perform or how to run a paired sample t-test in some random data, okay? Please, this is not real data, this is not real persons, okay? So, let's go. let's look now for our hypothetical research problem. So, psychotherapy helps to improve emotion regulation skills. However, this assumption must be explored. So, we can transform this research question into an operant condition, such as emotion skills increase after psychotherapy. So, our new hypothesis is there is no difference between a pre-test and a post-test condition, okay? And age one, our age one hypothesis means that we have a difference between these means. So, as in the other research problems, here we want to reject the null hypothesis, because the null hypothesis means that there is no difference between the pre and the post-test condition. So, if this is true, it means that the psychotherapy does not improve or does not increase the emotion regulation skills. So now let's jump to the SPSS. So now we are here in the SPSS environment, and I'll show to you how to perform or how to run a paired sample t-test. So, if you look here, we have our two variables, emotion regulation before a psychotherapy process and emotion regulation after the psychotherapy process. So, how can we perform one sample t-test? We go here to analyze, okay? Then we go here, compare means, and we just choose here paired sample t-test, okay? We click here, and then this box will show. On the left we have our variables, and we will choose the variables that we want to compare. So it's emotion regulation pre, go here, and emotion regulation post. It will go to here, okay? We look to options, we just leave the standardized values that the SPSS gave us, 95%, and to exclude cases, analysis by analysis, okay? So also, it's pretty simple to perform this test. Then, we just click OK. So what we have here? We have here these tables, okay? In this table we have the mean from the first variable, the n, and the standard deviation. Then we have the other mean for the second group, okay? The second mean, the second observation. This is 3.5 and 4.1. So here we have a paired sample correlation, which means that there is a significant correlation between this pair, okay? It's a correlation at 0.61, and as you may see, the significant value is below 0.01 or 0.05, which means that this correlation is significant. And here we go to the third table that shows us if there is a statistical significant difference between the first mean to the first mean. So here we have the difference, okay, and the standard deviation. Here we have the confidence intervals that we have for our difference. Here we have the value of the t-test. Here we have the degrees of freedom. And then finally, here we have our significance for our paired sample t-test. And as you may see, this value is below 0.01 or 0.05, which means that the difference between the first mean and the second mean is significant. Therefore, we may imply that the psychotherapy may increase or may boost or may develop new regulation skills which may be object or may be identified by paired sample t-test. Okay? So, again, here we have your difference between means, the standard deviation, This is the standard error, okay? So here you have the lower confidence interval and upper confidence interval, the two margins, okay? Then we have here the t-test, the value of t-test. Here you have the degrees of freedom, and here you have the significant value, which means that the difference between the first mean and the second mean is significant. So I hope that you enjoyed the content of today, and don't forget to see the video's description regarding today's theme to look to the references that I think that are very useful to understand these concepts. Also, if you like what I'm doing here, please consider to subscribe and hit the bell button for notifications. Also, if you want to say something about these topics, please use the comment section below to express your mind. Welcome to the Mind Brain Talks, and I hope to see you in the next video. Bye! Hello everyone, welcome to Mind Brain Talks, the place where you find diverse and scientifically accurate information regarding psychology, psychotherapy, neuropsychology and neurosciences every single week. My name is Bruno Faustino. I am a licensed clinical psychologist and neuropsychologist who's been working as a therapist, researcher and educator for the past few years. Here, I discuss and describe lots of topics, research findings and methods regarding psychology and neuroscience for you to understand it and for you to learn something about it. All videos here are just for educational purposes and it's not intended to diagnose any psychiatric condition or neurological disorder. So, without further delay, let's jump for today's content. I've used these 4 manuals to prepare myself to develop this video, and I think these 4 manuals are very good in explaining how we can use statistics and how we can apply statistics to every kind of psychological problem and how we can perform these tests in SPSS. So if you like what you're seeing here, please check the video description and you will find there these 4 manuals. So today I will show to you how to perform the independent sample t-test. I will show to you how to do it in the SPSS, but first, and as usually, I will show to you some notions, some assumptions that we must have before performing this test. So let's go! The independent sample t-test is a statistical test that is used to explore if the means of two independent groups, such as different means of two group scores, are statistically different. Normally, it's a measurement of the same observation on the different time or in the same time, okay? Which means that these groups must be different. So, it is a parametric test. And really what we want to know if there is a statistical difference between 2 points, 2 conditions, 2 measurements or a matched pair which is not the same observations, okay? What we want to know is the difference between 2 means which belongs to different conditions, and these conditions are not in the same sample, okay? That's why the test is called independent sample t-test. So now let's see the independent sample t-test parametric assumptions. So dependent variable must be continuous and independent variable must be categorical, such as group 1 or group 2. We must have a random sample from a population, okay? We expect to have normal distribution. Also we expect to have homogeneity of the variances, and as usually we expect to have no outliers in our sample. Now let's look to our hypothetical research problem, okay? Individuals in clinical groups tend to manifest lower skills than individuals in non-clinical groups in emotion regulation. However, this assumption must be explored. So, we can develop an operant condition such as individuals in clinical group has lower means in emotion regulation than individuals in non-clinical group. Our null hypothesis is usually no difference between these two means, and our H1 hypothesis is to have a difference between these means, and our p-value normally it will be 0.05. So now let's go to SPSS. So now we are here in our SPSS environment, and then we have our variables right here. So here we have emotion regulation, and here we have our sample. So this is the second sample, okay? And here you can find the number one sample. So here this variable is divided in sample 1 and sample 2, okay? So this is the variable that it will be defined as categorical in independent sample t-test. So now let's see how to perform this analysis. We just go here to analyze, compare means, okay, and we have right there independent sample t-test. We select here, okay, we have here this grouping variable and this test variable. We will choose the variable emotion regulation, okay, and we will choose here in the grouping variable sample. Now we must define groups, okay, we press here, and then as you saw our variable is defined in group 1 and group 2, so we can just group 1 and group 2. We will not use a cut point, okay? Options. It's the same as the paired sample t-test. We will use the 95 confidence intervals, and we will exclude cases analysis by analysis, okay? We will not perform bootstrap in this analysis, so okay, let's go. Let's see. So the independent sample t-test gives us these two tables, okay? Here we have our sample size, okay, 231 for non-clinical sample and 66 to our clinical sample. As you can see, here are means, standard deviation and standard error. So let's go to the second table. The second table, we can see that there is the variable here, emotion regulation. Here we have the Levine test for equality of variances, okay. We have test here, the significance here, okay, and then we move to independent sample t-test, which is this value right there and the degrees of freedom right there, and then we have our p-value here that is, in this case, it's higher than 0.05. So as you can see, our means are not statistically different. So in this problem, we cannot reject the null hypothesis, because the null hypothesis is the absence of meaning, the absence of effect between our mean groups, okay, between the mean of these two groups, as we may see, our p-value is not significant. Therefore, there aren't differences between emotion regulation in these two samples. Okay? So, this is a different problem, and therefore we cannot reject the null hypothesis. So, I will show you here the other two values. Here we have the t-test for equality of means, okay, and the confidence intervals. However, what is important here is these values. This is the statistical test for t-test, and this is the p-value, which is higher than 0.05, which means that our hypothesis it's not confirmed. Therefore, we must accept the null hypothesis because there is an absence of effect. Okay, and that's it. So I hope that you enjoyed the contents of today, and don't forget to see the video's description regarding today's theme to look to the references that I think that are very useful to understand these concepts. Also, if you like what I'm doing here, please consider to subscribe and hit the bell button for notifications. Also, if you want to say something about these topics, please use the comment section below to express your mind. Welcome to the Mind Brain Talks, and I hope to see you in the next video. Bye! Hello everyone, welcome to Mind Brain Talks, the place where you find diverse and scientifically accurate information regarding psychology, psychotherapy, neuropsychology and neurosciences every single week. My name is Bruno Faustino. I am a licensed clinical psychologist and neuropsychologist who's been working as a therapist, researcher and educator for the past few years. Here, I discuss and describe lots of topics, research findings and methods regarding psychology and neuroscience for you to understand it and for you to learn something about it. All videos here are just for educational purposes and it's not intended to diagnose any psychiatric condition or neurological disorder. So, without further delay, let's jump for today's content. So, today I will talk about a statistical test called One Way ANOVA, okay? And I'll show to you how to perform it in the SPSS, but first I'll give you some notions about the ANOVA and I'll give you some information for you to understand how this test works and how you may utilize it in your statistical problems, okay? Let's go! I've used these 4 manuals to prepare myself to develop this video, and I think these 4 manuals are very good in explaining how we can use statistics and how we can apply statistics to every kind of psychological problem and how we can perform these tests in SPSS. So if you like what you're seeing here, please check the video's description and you will find there these 4 manuals. One Way ANOVA, called the analysis of the variance, compares the two means of 2 or more independent groups and tries to explore the statistical differences between these means. The difference between the one sample t-test is that here we can compare more than 2 groups, okay? Also, it's a parametric test. And One Way ANOVA allows to contrast in the post-hoc comparisons to see which specific pairs of means are significantly different within different samples or groups, okay? We can test more than 2 groups and then we can compare specifically which differences are between each means of different groups. We can pair specific groups to see if there is statistical differences between means, okay? So, if we have 3 groups, for instance, we can compare these 3 groups, okay? So now, let's look to the parametric assumptions of One Way ANOVA. The dependent variable must be continuous and independent variable must be categorical. We need a random sample from data population and we need a normal distribution. Also, we expect to have homogeneity of the variances and we expect not to have outliers in our sample. Now let's look to our hypothetical research problem. So, let's see. Individuals in clinical groups and waiting lists tend to show higher symptomatology than individuals in non-clinical groups. However, this assumption must be explored. Now we can infer some apparent condition, such as individuals in clinical sample and waiting list show higher psychological symptoms than individuals in non-clinical sample. Our age 0, our null hypothesis, is that there is any difference between these means, and our age 1 hypothesis is that we should find a difference between these three groups, a difference between the means in these three groups. Okay, so now let's go to SPSS. So now we are here in the SPSS environment, and as you can see, we have our sample, okay, our variable related to the sample. We have sample 2, sample 1, okay, and sample 3, okay. So now, and we have here the other variable regarding our hypothesis, which is symptomatology, okay. And then I'll show to you how to perform a one-way ANOVA, okay. So we just go here, analyze, compare means, then we move to one-way ANOVA, okay, right there. Select and select ANOVA and shows this table. Now we will select symptomatology and our sample. So as you can see, we have this menu regarding contrasts, but we will not choose nothing, okay? But we will choose here the bufferonic corrections to see the post-hoc comparison, okay? As I said before, this comparison allows us to understand the differences, the specific differences between the three means of the three different groups, okay? So, okay. Here we will not choose nothing, okay? Because this video it's only about ANOVA, okay? And let's just press OK. So we have these two tables. As you can see, the comparison between groups, okay? Here we have the sum of squares, degrees of freedom, the mean squares, the F, the value for ANOVA, and our significance, okay? As you can see, our p-value is below 0.5, therefore there is a significant difference between the three means of these groups. And now we can see here the multiple comparisons. As you can see, we have the non-clinical compared to the clinical sample and the waiting list. As you can see, they are all significant differences. Here we have the clinical sample comparing the mean with the non-clinical sample and the waiting list. As you can see, the difference between the clinical sample and non-clinical sample is different, okay, statistically different, but from the clinical sample from waiting list there is not a significant difference between these two means. As you can see, the p-value is higher than 0.05, okay? And here we can see that the waiting list mean it's different between the non-clinical, okay, because it's below 0.05, but, and it's the same result here and here, it's not significant for the clinical group. So this means that the individuals in the waiting list and in clinical sample do not have different values on symptomatology, okay? But when compared to the non-clinical sample, as you can see, there is a significant difference between these two means, which means that individuals in a non-clinical sample have a value in symptomatology, and individuals on the waiting list and on clinical samples do not have a difference between these two means, okay? So, I hope that you enjoyed the contents of today, and don't forget to see the video description regarding today's theme to look to the references that I think that are very useful to understand these concepts. Also, if you like what I'm doing here, please consider to subscribe and hit the bell button for notifications. If you want to say something about these topics, please use the comment section below to express your mind. Welcome to the Mind Brain Talks, and I hope to see you in the next video. Bye!